Hello, Science 9. Today we're going to take a look at polyatomic ions. First, I want to say most of the stuff on this video and this set of handouts is not actually testable. It's not something that you need to memorize or get too worried about. But I find if students don't understand what a polyatomic ion really is, or how it bonds and why it bonds and how it works, they get really confused just in the naming and formulas. So this is what we're going to do today is like, what is a polyatomic ion and why does it kind of bond the way it does? So monatomic ions, if you remember, monatomic ions means that they have one atom. And they have a charge either because they have lost electrons, maybe because their valence shell was almost empty, or they have gained electrons. Okay, and that would be because their valence shell was probably pretty close to being full. Okay, and if they lose electrons, they become positive. If they gain electrons, they become negative. Polyatomic ions, poly means many. Hopefully you got that on your own. Poly means many, so we have a many atom ion. So it's many atoms with a charge. And in a polyatomic ion, we have many, or at least more than two or more, atoms bonded together. And they are bonded together covalently. Okay, so in between my nitrogen and my oxygen, there are covalent bonds. Okay, covalent bonds. And if you remember, in a covalent bond, what are they doing with their electrons? They are sharing their electrons. Okay, and the reason that we're getting a covalent bond there is that because oxygen is a nonmetal and nitrogen is a nonmetal. And when you have two nonmetals together, they bond covalently. Okay, everything's changing size on me. There we go. So a nonmetal plus a nonmetal gives us covalent bonds. Okay? Now, somewhere in all of this mess, this NO3 ion, which we would write on its own as NO3 with a minus, it has one extra electron somehow. It has all the normal number of electrons you'd get from having 3 oxygens and 1 nitrogen, but there's one extra. Okay, and if you're interested in seeing the Lewis dot structure of what a nitrate ion looks like, this is it. I'm not going to get into too much on this. We would actually put some brackets around here and a -1 charge. Okay. The key thing about a polyatomic ion, though, is that a polyatomic ion acts as a single unit of charge. Okay, it acts as a single unit of charge. So we don't treat it as a separate N and separate 3 O's. We treat it just as NO3. Okay, so let's say that we were looking at a compound formed between magnesium and nitrate. Okay, this is magnesium nitrate is the name of the compound. It's made of a magnesium ion, and remember magnesium is an alkaline earth. So in your periodic table, magnesium is going to be, okay, and I ran out of room, we can't draw the rest of it, but magnesium is going to be about here. Okay, so its charge, remember things in group 2 have 2 valence electrons. And so when they become an ion, they will lose those two and they will become 2 positive. So our magnesium here has a 2 positive charge. Our nitrate, which is NO3, okay, nitrate is NO3, and remember it has a negative charge. If we write a negative like that, it's just -1. Okay, and in order to have a neutral compound, because remember, recall, all compounds are neutral. Nature does not like us to have extra charge, doesn't like to have an overall positive or an overall negative. So if we have a +2 and we have two things that are -1, then our overall charge, we've got a +2 and we've got -2, and that's going to give us an overall charge equal to 0. Okay, and one thing I want you to notice here, when I wanted to say that I had 2 of the nitrates, we put the NO3 into brackets there. So just like in math class, if you want to multiply like an entire thing, you put it in brackets. So, let's say you had x plus y in a math class and you wanted to multiply the whole thing by 2, you'd put it in brackets and say 2 times that. Well, in chemistry, we do the same thing. We put the brackets around our polyatomic ion, and then we put another subscript on the outside to recommend that, or to significate. I am using all kinds of words that don't mean anything today. Show is a good word, to show that we have 2 nitrates. Alrighty. So we're just going to meet a whole bunch of polyatomic ions. You are not expected to memorize these, okay? There are very, very few positive polyatomic ions. There are only 2 positive polyatomic ions. One of them is ammonium, which is NH4 with a plus, which means we have 1 nitrogen and 4 hydrogens and an overall +1 charge. And the other one is mercury 1, which is a really bizarre little thing. Metals don't normally do this, but this metal does. Mercury, the symbol for mercury is Hg, and it never comes as a singleton. It always comes as a little pair of atoms, and it has a 2+ charge. Now, why on earth would that be mercury 1? Because mercury 1 means mercury has a +1 charge, if you remember your Roman numerals. Well, what we've really got is we have an Hg, and it has a +1 charge, and it is bonded to another mercury with a +1 charge. So you can see that each individual mercury has a +1 charge, and that's why it is mercury 1. But because we have 2 of them actually attached together, the overall polyatomic ion has a 2+ charge. At any rate, so those are our 2 polyatomic cations. Let's take a little closer look at ammonium. This is our ball and stick model over here, okay? And it's pretty useful because you can see how things are attached to each other. I want you to answer this question for yourself, so pause for a moment. What kind of bond is holding the nitrogen to the hydrogens? What kind of a bond is attaching the nitrogen to the hydrogens? Pause if you need a minute, and then come back and I'll answer it. Okay, all of these bonds, they are all covalent bonds. What are they doing with their electrons? Sharing them. And why are we getting covalent bonding? We're getting covalent bonding because it is a non-metal and a non-metal. Okay, and yeah, there we go. The space filling model, it's kind of useful because you get to see what the molecule or polyatomic ion would really look like. Yeah, so there we go. Oh, let's just go back one page because I forgot to draw something in here. Okay, remember within our polyatomic ion, we have these covalent bonds attaching the nitrogen to the oxygens. Yeah? But once we form the compound with nitrate and magnesium, okay, I'm going to grab a different color here, maybe some green. So in between the nitrate and the magnesium, that's not a covalent bond. That one is an ionic bond. Ionic bonds occur between ions. Okay, an ionic bond occurs between ions. Okay? Maybe I should get rid of that thing there. Oh, there we go. Okay? So within the compound magnesium nitrate, you have covalent bonds within the nitrate polyatomic ion, but between the magnesium and the nitrate, you have ionic bonds. Okay. Back down here to another ionic compound. Okay, ammonium chloride is an ionic compound. It is made of the ammonium cation. So our cation is ammonium, and the anion is chloride. Okay? And every single ammonium has a +1 charge. So all of these guys here are all positive. And all of our chloride ions, if you recall, chloride is in group 17. So it will have 7 valence electrons, so it needs 1 extra, so it's going to be Cl minus. Okay, and all of our chloride ions have a -1 charge. So in between the NH4 plus and the Cl minus, what kind of a bond do we have? We have actually not we have an ionic bond. How do we know it's an ionic bond between the NH4 plus and the Cl minus? Well, because it is between a positive ion and a negative ion. Okay, remember, an ionic bond is between a cation and an anion, the positive ion and the negative ion. Okay, and the diagram over to the right is just kind of showing you what it would look like if it were arranged in a cube. It's really hard to draw that in more than 1 unit. So we very often draw it in 2 dimensions instead of 3 dimensions. Okay, And I'm not going to do this for very much longer today because otherwise you'll get extremely bored. So I'm going to split this up over a couple of days. But we will just carry on down here and finish off ammonium. So here's ammonium oxide. Now, if you remember, oxide is -2, and compounds must be what charge? Compounds must be neutral. In other words, their overall charge has to equal 0. Okay? And if oxide is -2 and ammonium is +1, we're going to need to have 2 ammoniums for every 1 oxide. So we're going to write our formula for that. We're going to signify that we have 2 ammoniums for every 1 oxide. And this is a 2-dimensional representation of what that would look like. If you went and counted all of these, you would actually find that we have 72 NH4s, ammoniums, and we have 36 O2 minuses, 36 oxides. And if we simplify that, that goes down to a 2-to-1 ratio. And there is our 2-to-1 ratio. Okay. Oh, and now we're moving into acetate. I'm going to leave acetate for next time. All right. Hopefully that wasn't too boring for you, and I will see you next time.